Hello and welcome. I'm Bill Wake. We're here working on an Elm interpreter. We're up to working on Lambda expressions today. I'm sorry I was late. Little family emergency. I'll probably have to take a medium-sized break later on and uh, go pick up my wife at the doctor's. Okay, so all right. So we left off. Let's see. Let me make sure. Yeah, we are broadcasting. Okay. We left off. We just started doing lambda expressions. So we're in the middle. We're trying to get definitions going. We've got a very primitive definition, and with which is like name equals value, and we want to get functions working. Well, functions, I think, translate into lambda expressions, and certainly a lambda expression can be a function. So we will go on that path. Let's see where we got. We do have a failing test somewhere here. Well, let's find this error. Okay, parser test. Yeah. So a lambda expression looks like backslash ID arrow ID, and we let's see if our lexer. Okay, we added the lexing of the lambda token in the arrow. Okay, so let's catch that. Um, that was last time. These two things. And we're still on lambda expressions. Now we need to parse them. And then later on, we're going to interpret them. That'll be fun. Okay. So we have our failing test. Lambda expression. We don't have a lambda expression object yet. So let's go create one. Sometimes we call this framing. You know, we just kind of get the basic structure up so we can do things. All right. So let's create a new file. It'd really be nice if I had this a little more kind of one step. Lambda expression. Yeah, I guess that's a real name. Okay, and we got class lambda expression implements or is an example of expression, and there we go. It takes a variable and an expression. The typing expression. All right. Doesn't. Okay. Super.init. Well, the type. Let's hold off on that. We'll make it unknown for now. I think on these unknown types are going to come back and get us, but all right, we're just trying to get compiling so we can properly fail our test. All right, let's see if that does it. It should fail to get a successful parse. Perhaps a crash on a no pointer, but certainly going to fail one way or the other. All right, I'm going to change the sound just to make sure you're getting the sound. All right, so check. Sorry, my mic appears to be registering, but all right. Usually I get to do that before the show starts, but today I kind of rushed in the last minute, so my apologies. Okay. It's starting to test. Let's move this over here. And so I think the type of this thing, a lambda expressions type, it's really a function from something to something. And I don't know how we know what that is. Like in this example, id to id, uh, it works for any type. It could be function from A to A, and maybe we infer that. I don't quite know. All right, we got an error expression. Good. All right, let's go into Lambda. And, well, we're certainly going to save name and save expression. And don't I wish my IDE would do that for me. Okay. Value has no member. Okay. Well, let's see. Elm error expression. I guess we're not even really parsing this thing at all. I'm probably jumping the gun there. Let's get to our parser. All right, variable expression. Do we have a token? Yeah, we don't really have token lambda. Lambda, and let's return lambda. Okay. And is that after expression? Okay. All right. So we come in with the lambda, the backslash. We'll skip over that. All right. We should see an ID. Well, requires not quite the right thing. Expects it. If we don't get it, it's more for things we just skip over. They're required, but we skip over them. Our arrow will be that. All right, so we can say try require token dot arrow at some point. So let's do this. Okay. Lambda. Okay. And we're just going to do the same thing as down here for now. I don't know if it can quite happen, but all right. So at this point, the token should be a name. So let's see, where did we did something like it, right? Yeah. So if case name equals token, so well, I'm just going to borrow and trim. Okay, so if case let lowercase name equals token, that should be the case token. Now we've got we want to hold. We're holding on to that name. Okay. If it's not a token, then it's an error. Okay, and then we're going to require the arrow token. Okay, and then we're going to call expression. So the right hand side of the arrow is an expression, and this is the recursive descent. So let's put the grammar up here. So it's lambda name arrow expression. Okay, And okay, so consume the lambda, make sure you got a name. If you do, save it. Skip over the arrow, call the expression. We need to capture that. All right, and then at the end, we're going to return lambda. And now we've got the name and we've got the expression. Okay. Cannot find name in scope. Let's put, I think I can say let name of string. Will that work? No. Well, we can move it this inside. Not totally terrible, but this arrow stuff, well, you get this sort of stacking structure of failures. I'm not a fan, but that's the way this stuff comes out sometimes. Partly this construction to get the name is a little goofy, but okay, so get the name, eat that, skip over the arrow, parse the expression, and return that value. That seems okay to me. Well, so much for that. Parser does. Lambda expression is not equal to lambda expression. So we didn't get the name we expected. And the reason for that is we have obligations as an expression. So let's pull up well, integer value is okay. So we have this EQ function we have to override, and if you don't override it, it fails to match your stuff. There's probably a better way to go about this. I don't know. I'm used to having the like abstract type things and sort of requiring it, and this is not really required the way I have. So I don't know. I'm missing a bit of something. All right, so excuse me just a minute. My morning spam call. Okay, sorry about that. Let's see. So our EQ function, we've got this other. We expect it to be a lambda expression. If it's not, we definitely don't match. Okay, and if it is, we expect self name equals other name. And, well, we also have expression, self dot expression equals other dot expression, okay, which also has an EQ function, so it's okay. All right, and let's check that. I feel like I should backfill a test for that, though. Huh. Okay. What is the problem? Parser tests. Well, let's break and see what we're looking at here. I think we'll just break right there. Oh, maybe I didn't make him equatable. All right, so we'll step over this. Print parser.parse. Elm expression type equals unknown. That's okay. Id Elm expression type equals error. So the id. Well, let's make sure our test is a reasonable test. Okay. Id failed to parse. Now, I would have thought. Okay, I would have thought when you called expression. Oh, variable is not a legitimate expression right now. I guess it should be. Let's look at this thing. Value of string. Variable of name. And it doesn't have a type yet. Interesting, challenging. Okay, let's try again. Let's just run one test. Just this test. Okay, print parser.parse. Let's continue. What's the matter? Well, that seemed okay. I don't know why the print didn't work. But we do have this now. Okay. Let's get Lambda expression. Let's fill in a test for this. Expression tests. Okay. And I got to install John's. John Reed put together a package of better templates for this. And I really need to get in there and use those. Maybe we'll do that in a few minutes. Okay, that's Lambda expression. Where's the tests? Wowzers, okay. Fingers are not working. All right. So this is function test equality. And the pattern we have is let expression 1 is Lambda expression. We'll give it a name of x equals a value. Well, we can do this. And we make a second expression that's equal. Let's see, this is 1a. This is 1b. I'm sure there are better names in the world. Let expert2 equal Lambda expression x variable. Well, let's do the two different ones. M variable y, and we'll do a 2a and a 2b just to make sure all the pieces are captured. So this will differ in the second one, and okay, so what we have 1a looks exactly equal to 1b, and 2a and 2b are not equal, so we'll just assert that. Assert equal x per 1a and x per 1b. And then assert not equal x per 1a and x per 2a and x per 1a and x per 2b. Okay, and I believe this will pass. I mean, we kind of used this capability in the test a moment ago, so it's, I talk about confirmatory tests, you know, I think they should pass. If I'm a little nervous, I will comment out something and make sure that things are covered. Okay, so 2b differs in the variable. All right, and then you see these names. The printing of this thing is pretty ugly. Let's work on that next. Where's integer variable as an example? Variable. Oh, well, variable isn't very nice either, is it? Okay, let's integer value definitely does as string. Okay, so we override this. Let's put a test in. Well, let's start with variable since we know it doesn't have it either. Variable tests. Test as string. Okay, and we'll make a variable. Name. And we will assert equal variable dot as string to I think that'll work. That actually I want that I gotta get this straight here. Okay, slash quote. Yeah, slash quote should be just a quote. And then I want slash parens name slash quote and the closing parenthesis for this one and close. Okay, I think that's correct. Let's get variable up here. Give it the stub. And we'll just give it junk. Okay, where's failure? Test equality. Oh, huh. Yeah. Let's take this back out and try again. Wrong is not equal to variable test as string, whatever that means. Oh, I guess I don't need. I know the answer is that. Okay, so let's make sure. We know it's wrong. Wrong is not equal to variable quote name. Yes, that's what we want. All right, so we would rather have it say variable. Well, now we need this. We need our quote and closing paren and an opening quote. And in here, name. Should pass. Right, and Lambda expression tests as string. Lambda expression. I'll just put the stub in again. And the test is similar. Well, not very similar, I guess, but okay. Expression tests. All right, so I'm going to make the name more generic. All right, so the name Lambda expression name goes to integer value 3 1 2 3 and elm type dot number. Okay, and we expect to get back lambda name comma 3 of number. I think is the way this will go. All right, should fail. I haven't been very good about checking in. All right, wrong, which is not equal to lambda name 3 colon number. Okay, I think I have the assertion though I want. Okay, in here we're going to print lambda that, and we're going to put a quote and another quote, and between that we put name. After the quote, we're going to put another value and a final parenthesis, and the value is expression.asString. All right. I hope it passes. I may have a little bit of a typo in there somewhere. All right, and commit. I'm trying to commit every time it's green, and I just am not getting the habit very well. All right, so we added lambda parser, lambda equality test, lambda as string, and variable as string. All right. Let's just take a quick 1 or 2 minute break. I'm just going to grab a drink and be right back. Okay, honest, it was quick. All right, let's see our to-do. So parse them, I think we have done that. All right, so 2021-002-17. Parse them being lambda expressions. Add equality test for lambda expression. Add as string for variable and lambda. Well, let's spell it out. Lambda expression. Okay. The thing that's funny. Okay. Let's go over and see the expression. Oh, let me see. Let's see if I'm supposed to be picking somebody up. Sorry. All right. We want to look at interpreting. So the evaluate function right now defaults to the parent, and it just returns error expression. Right. We really got to get error messages improved here. Provide error messages. I'm going to say that's more important than our function calls. It's getting ugly. Now, a lambda expression, the result of it is it's a function. Sorry. Okay. So the value we need to do in evaluate, and let's I think I have a terminal here. Yeah, let's take a look here. So Elm REPL. If I do lambda n goes to n, I get something back. Okay, I get a function a to a. All right, and that's an entity just like integer 3 is an entity. We can see the type is a function, and the a comes in because that's a generic. So end to end, I don't know what n is. It could be an int, it could be a string, it could be anything. And so I think we need to put the variable type needs to be like generic, and the result of the lambda needs to be a function coming back. It's well, maybe we need to work on the variable first. Let's do that. I'm going to put this in. Okay. I'm just going to totally stack this up. Let's do variables have a generic type, and it's really until proven otherwise. Okay. Yeah, let's go with that. Is this there's something funny. My my little Chiron is not updating. I'm a little puzzled there. All right, so let's. Well, that was my call. I have to run out, and so we need an actual longer break. It's probably 15 to 20 minutes. So Let me, let's see, that we don't need. Let's see. So we left off. Variables have a generic type until proven otherwise. So the example we have, function a goes to a, and the deal is in the context. Oh boy, I think in the context of a lambda expression, the argument type is generic until proven otherwise. We can. I'm trying to make sense of it. That a goes to a. So I think we're saying it's a generic type n, basically because of the lambda. We have nothing to contradict to that. And in the context of that, the variable n has the type a. Okay, so, Ow. If we just do an n, it's undefined. It's not a variable yet, but if I do n equals 3, n is 3 number. Gets substituted. Wow. All right. Well, let's look at variable. So we do unknown. Yeah, we're stacking up a lot of a lot of issues here, I think. One is we have a symbol table, and the lambda n should be in that symbol table by the time we evaluate the expression. And the expression's type should, well, if the variable's type should be whatever the type of the lambda argument is. And it's a generic. Sorry about that. All right. Wow. Like, what's the test, right? in the context of this name, well, we evaluate it. Maybe. Okay. Wow. I don't know if we're evaluating it in the sense. Huh. I need an Elm expert and a Swift expert here, obviously. So there's something about it. Well, its type should not be unknown per se. Its type should be the type in the. If we look it up, not to evaluate it. Well, we're evaluating in a context, right? Maybe I need to look at the lambda again. What does it mean to evaluate the lambda? Lambda n goes to something. It's sort of to create a deferred function, right? I mean, a deferred evaluation. But it's got a type. I mean, we should be able to assess the type of this thing. Oh, man. Okay. Well, John the other day said, this isn't your mama's uh, fizz buzz, and I gotta say that's true. We're in a kind of tricky area here. It would be nice, I just don't have the background in the functional language stuff to know off the top of my head how this all hangs together. Um, I did do Lisp 1.5 stuff back when, and there basically they had this list, and you would stick the variables on the list with their values, and then just look them up, and there was no strict typing, so you didn't have to worry about that side of it. Um, what is the type of a variable? Can I know that at at front? Well, it may be that the type is generic. Um, Maybe that would be a better expression of what we're looking at. Um, I think we could do that. Let's see, variable tests. Let's add that. Test variable has generic type. Um, well, it doesn't, does it? Oh, this is hard. Well, basically, we're saying the type. I don't know if we know the type until you evaluate it. Um, hmm. I guess if you just create a variable, the type is generic, and it's actually the definition is going to change it from generic to something else. So, how about variables? Variable has generic type. Okay, um, so if we take variable subname, we expect Elm type dot generic, which doesn't exist. Okay, and case generic, and maybe that's the same as unknown, but we'll see how that goes. Okay, this test should fail. Well, I'll just call it generic for now. Conflicting type arguments. Oh, how about variable dot type? No, this should still fail. Unknown is not equal to generic. Yes. All right, and then we'll just put that here, and should pass. Okay. um, variable starts with generic type. Okay. I think that's true. Okay. Now, when when let's see, we got the assignment statement. So let's find one of those. Custom value if yeah, this is starting to get a little long. There's definition. Okay. X integer 3. And let's see what happens when you evaluate a definition. So, okay, so we say a definition is expression.type. That's progress. Okay. Let's go back. Let's go to our lambda. Well, we said unknown. It's not really unknown, right? It's a function of expression. Well, it's sort of a function of generic goes to expression. So the name defines a generic argument as of right now, as far as we know. We might be able to update it later, but that's the way it goes. So I'm saying, what am I saying? I'm saying test type. So if I let expression equal lambda, x goes to x. Well, let's take an easy one first. Can we do this? Integer value 3 elm type dot number. Let's type with number. Okay. And what I expect to get from expression.type, well, I expect elm type of a function from elm type generic to elm type dot number. Is this right? Admitting that function doesn't exist. Okay, so the first argument goes to the argument type goes to the type of the right hand side. The argument type x is generic as far as we know, and the type of the right hand side is elm type dot number. Okay, and we need a elm type dot function. Okay, so let's add a case function. I don't know, that's kind of a more complicated case. Let's go down here, maybe break up this from that. Okay, so a case function, and it's going to be of type input of elm type and output of elm type, and we had to make an indirect enum. And we went down this path before and ended up creating a class, and it was kind of hassle to switch over, but we will see. Okay, now when I build, there's going to be lots of people who don't know about function. Elm type has no member function. Well, that's not really good enough. There we go. Okay, so format type. Well, that's a good test. The hashable, I'm okay doing it. Case.function let input type let output type colon. Oh, he's not in this case. And we're going to combine input type and output type. Okay, but let's add a test for this. Elm type tests. There we go. Test function. What was the thing called? Format type. Okay. Let type equal elm type dot function with a generic. Well, generic is sometimes A and sometimes B, so I don't know. That's a little hard. Let's we'll have to come back around on that one too. Okay, the type of generic and the elm type of number. Okay, and we're going to assert equal type dot format type should be a string. Function goes to, well, for now we'll say generic goes to number. I think elm type has no member function. Okay. I think that'll at least let us compile. Okay, missing argument output. I expect the test to fail. I hope it compiles. Yeah, saw something go wrong. Okay, type with number. Oh yeah, we're really testing this one first. Failed is not equal to function generic goes to number. Okay, so let's go back to Elm type. Function case. Okay, so this thing we would like it to be function goes to something goes to something. Okay, and this we'll have to say let and in this case we want to do input type dot format type goes to output type dot format type. Okay. So I expect one test to pass and one to fail. All right, who passed and who failed? Elm type tests. This one passed. Okay. This one still fails. Let's take what we got. Just momentarily, I'm trying to be conscious of the moves I'm making when I do TDD, because I have an article coming out on that this afternoon. This one I realized last night or early this morning. There's sort of a move we make that's push the testing context, go do something else, pop it, come back and do the real thing, and that's what we just did. But let's see, add a Elm type dot function and format it. Okay, so that was kind of a pushed on thing. Now we're popping off and back to our original failing test. So, oh boy, what are we getting? Unknown. Oh, okay. So yeah, our type of a lambda expression should be that. Yeah. Okay. And where do we calculate that lambda expression? We hard coded it to unknown. Okay, but it really should be elm type dot function with elm type dot generic. Whoa, generic. And expression dot type. Okay. And let's see how that goes. All right. Give lambda a function type. That's a good thing. Okay. I feel buried in all the stuff going on for this, but that's all right. Okay, so story variables have a generic type. I think we've done that per se. Okay. Lambda expressions, well, not interpret them. We said lambda expressions have a function type. Function type. Okay. And that's good. Interpret them. Well, oh boy. Oh, what does it mean? So I just don't know. When you evaluate a lambda expression, not calling it, just saying I'm evaluating it, I should get back. And this is basically like closure land, right? We're saying I'm going to get back an anonymous function. It should capture, and this is where I'm not quite sure how it goes. This anonymous function should capture the environment it's in, and it's got to kind of create its own little extra environment. Gosh. Now maybe we need to work on our symbol table a little bit first. I don't know. We want to capture the generic environment. Now when you do a function call, we're going to evaluate your function call with that environment that it has. Wow. Okay, so this one is, I don't know the story, but we'll say access proper values from symbol table / context. Oh. Okay, so the case I'm kind of thinking about is if I do this, I do x equals 3, lambda n goes to x plus n, and I call that, well, I could say function equals lambda n goes to x plus n. All right, and if I call that function of 2, it should get 5 for the value, because it should have captured the x and done it. Okay, so let's play in here. Okay, so n equals 3, function equals lambda. I'm going to use n. No, I'm not. I'm going to use x goes to x plus n. All right, and if I call function with 2, I get 5. If I say n equals 4 and I call function of 2, what do I get? I get 6. So it hasn't like frozen the variables at the time, right? It doesn't evaluate n. It just captures that it wants to know n maybe from this context, from this outer context. Okay. Now if I just say function, it says you have a function ready to go. Okay. I'll comment these. And this is an example. Okay. Well, I'm thinking it's time for an actual break. So just a 2-minute break, and we'll come back and figure out what's the next step. I think the next step is maybe it's this symbol table. I think maybe this is the thing to do next. Because when I create this function, it needs to work with the symbol table in a way that we inject in, but we don't put it in a more broad context. So in our thing here, I have lambda x, but x is not a defined variable at this point. That's inside the lambda, So welcome back. All right. Where are we? We're going to get the symbol table working better. All right, let me close all these. I guess it's just a sign. To do is modify, that's fine. So symbol table. Yeah, right now we just have add and access. But a symbol table in this environment, I mean, if you were creating a basic interpreter, okay, or even to some extent a Fortran interpreter, but let's stick with basic because it's pretty basic. Basic interpreter has a bunch of variables. Some of them are integers, some of them are strings, and there's no nesting, there's no parameters or any of that stuff. So you could have a symbol table like this that's just a name goes to some value. Excuse me. In more sophisticated languages, you have names that apply in different contexts, and this symbol table doesn't handle that because it just throws everything in the same bucket, that table field. It's well, yeah. So we would like a symbol table that says look for a name in a context. So we want to treat each symbol table as a context. So look for a name in a context. If you don't find it in this context, look in the next outer wrapping context. And so as we had here, here, we had n defined in the outer context. And when we call function, well, when we maybe it's here, we've sort of captured the fact that we're grabbing this outer context and getting the n from there. And we've sort of said there's an inner context where x is defined. And when you call function, it plugs in 2 for the x, evaluates the expression. When you hit the x here, it says look it up, and it looks up in the context with this defined and finds the x, which is 2. But it needs the n, and it has to go look, and it doesn't find it in the local context. It finds it in the outer context, and accesses it there, and then function of 2 adds them together. Okay, and this proves this n equal 4. If you update the outer context, it still is looking in the outer context. It doesn't freeze it or anything like that. Okay. So from a functionality point of view, symbol table. All right. So I'm going to kind of reinterpret what I have here. So if you put something in the symbol table and it's found in local table, local table, current table, inner table. Well, it's found in the table. Maybe it is found as okay. Undefined value returns nil, but we want to make it so that it looks in inner tables. So defined value is found in inner table. Outer table, really. Okay, so we're going to let outer equal symbol table, and then we're going to let inner equal symbol table of outer. Okay, and we're going to put a variable in outer, which I guess we could do up here. Table.add x. We'll keep using the integer value. How about value is looked up in outer table when not found in inner table. Okay, so we got a symbol table with a variable x and symbol table outer, okay, which we don't support yet, but we'll do that in a moment. And we would like to say assert equal. If I look in inner for x, I'm going to find integer value 3 elm type dot number. Okay. Look up inner, you still get the value from outer. Okay. Now, the symbol table does not take a symbol table argument just yet. So we need to add that. Init, you can give it a outer table. Well, since this is a design pattern, let me look up and use the words they use. Chain of responsibility 220 something. 223. Okay. Oh, I guess they vary. They got handler. I don't like that word. So chain of responsibility, the example they have in design patterns is if you have a GUI and you've got these components layered on top of it, and you click on a button, you're really clicking on a button that's part of a field, that's part of a something, that's part of a window, and when you click there, it's sort of like, hey, whoever's in front, try and handle it. If you can't handle it, go to the next person. So if I click on, I don't know, maybe buttons, maybe not the best example. If I have, well, I have some component, it's got some parts that respond and some parts that don't. The parts that don't may say, oh, I don't handle this. If you click on a label, it doesn't handle it. It says, well, I don't handle it. Maybe my next component outside handles it. And the form that contains the label may have a reaction. So, but handler doesn't fit our context. So I'm going to say outer table, and it's a symbol table optional equals nil. Okay. And we're not going to save it just yet. We're just trying to get our test failing properly. But I'm saying you may pass in a symbol table. If you don't, it'll be nil. And that way all our current symbol table uses don't break. We may regret that, but somebody's got to be the outer table and take responsibility for the whole thing. Okay, unexpectedly found nil. Yeah. So we got inner of x. It doesn't do anything with outer yet. It just uses inner, and inner doesn't have any symbols in it. Okay. Value is looked up in outer table when not found in inner table. Yes. All right. And I think there's another test we can make that these will both pass and fail together, but do I want to do that? Well, let's do it. So, a identical value in the inner table shadows value in the outer table. Okay, so if I put x with 3 and x with 42, and I look up x, I expect to get 42. I think this test will pass the way it is now. The first one will still fail. But, so it's what I know. Unexpectedly found nil while unwrapping an optional value. Oh, because I didn't put it in the inner. Okay, let's try that again. Yeah, that first one fails, second one passes. I just had a little space there. All right, and we want that shadowing behavior. That's the whole point of this chain of responsibility. And then the final one is it's a variant of this undefined value in how about value not in any table returns nil. Let's do this outer thing again. Well, this will work too, I guess. Well, let's call this outer. And let inner equal symbol table with outer. And if you try and look up bar, it should fail. And look it up in inner. Okay. And again, I think this will pass currently. We want to keep it passing. Do I have a breakpoint? Oh, okay. Let's just run this one test. I mean, since it's not looking at outer, we don't expect it to have an issue. Okay, so I put up some guardrails basically. Current, I'm calling it confirmatory tests. They just double check that something that we think should be true is already true. And in our case, they're also guarding that something doesn't become false. All right, so the real focus here is this one. We've got the outer symbol table with X, inner symbol table with no X. We try and look it up in inner. It should default. It should not find it there and try finding it in outer. Okay. We need to save the outer table. Well, we don't really change it. Outer table of symbol table. Okay. Outer table. All right, now we want to use it. All right, so adding is fine. We just add to table. Maybe this should become inner table, but we'll deal with that shortly. All right, adding it, you add it to the inner table because that's where you were told to. But accessing it, if we don't find table subname, if we don't find it in the inner scope, we want to defer it to the outer scope. Outer table dot sub name. Okay, now if the outer table is nil, yeah. So it's a little bit of extra question marks, but if the outer table is nil, we don't want to look in it. All right, so look up the name in the inner table. If you don't find it and the outer table exists, look it up in the outer table, and if the outer table doesn't exist, just return nil. Should pass. All three should pass. All right, and okay, so let's say make symbol table a chain of responsibility. Looks up inner table first, then outer. There could be more than one. Okay. I mean, you can't complain too much, right? I mean, that's not a super big change. It didn't change the fundamental nature of our class. All right. So now we're saying a symbol table. Oh boy. You have an outer table and an inner table. We store the outer table. If you add something, you're adding it to the inner table. If you look it up, you're looking it up in the inner table, and if you don't find it there, you're looking in the outer table. Okay, that's pretty good. So we refactor, rename table to inner table. And I'm just going for that symmetry, inner and outer, and I think it'll be okay. Well, I thought that would take longer, frankly. It's like I want a little time to figure out what to do about this Lambda thing. All right. So access proper values. So look up symbol in innermost context if possible, otherwise How about lookup symbol in innermost context that includes it? Well, that's redundant, isn't it? Okay, well, I think that's enough to get the idea. How about lookup symbol from innermost to outermost context? And we did say that a symbols may shadow other symbols. Shadow's a term with well-defined meaning in this context. If you defined X in two contexts and you can't really get to the outer one directly, at least with the facilities we have. Oh my. Okay. Let's go back to where we left off on lambda. So what I think it means to evaluate a lambda expression, what does that mean? I think it means you give me a context. I take that context, I wrap it in a new context with my lambda argument, like n in line 16. And I keep that as the definition of the function. I think, maybe. Oh. Okay. So what does it mean to evaluate, interpret it? All right. Let's have a go. Lambda expression. We don't have an evaluate at this moment. And here we have a test. Oh man. I hate that. I opened the file because I wanted it opened. If it would default to opened, I'd be happier. That's the truth. Okay, I don't know. I probably should check every time I update Xcode because maybe they've finally come to my way of thinking, right? Okay, so lambda expression tests. Test evaluate. Okay, so if I make an expression, lambda expression, name equals integer value 42 elm type number. Okay. That's a valid expression. If you evaluate it in a context, how can I tell that the context has changed? I think I'm just saying there's a function node. So evaluating this, I believe, will produce a function with a properly captured environment. Let's translate that. Let expected equal function, which is a new thing, and it is do I really want to do symbol table equality at this point? Just for testing? Well, somehow, somewhere, I think it's got to have this value somewhere, right? And it's got to have a symbol table. Oh, man. So we're not evaluating the function, we're creating the function. This is where I got to be careful. But I'm going to say symbol table. And let's expect the symbol table. Oh, what is this going to mean? I'm going to catch the symbol table that I start with. Okay, let's do symbol table dot add y is integer value 25 with Elm type number. Okay, so that's the context I'm evaluating this thing in. I'm going to expect that I get that symbol table, and I'm going to call expression dot evaluate with symbol table, and I expect expected. Oh, okay. I don't know where a name comes into this though. Do we still need... Maybe we still need name coming in here. Function is a symbol table with... It's a parameter? I don't know. Let's try it. And maybe this is a one argument function? I don't know. We want symbol table, we want name. So when I evaluate function, okay, that's gonna be harder. Evaluating function, I want to pass in the value, assign name, create a symbol table with name assigned to that value. That's what it means to evaluate the function, but we're just creating the function here. Yay. All right. We need a new type. Okay, so new file, Swift function. I don't think that's a reserved word. Class function is an expression. Okay. Okay, and we had an init. Where's our type test? Symbol table, name, and an expression. Maybe it's a lambda expression. Oh boy. What if we what if we said the evaluation of a lambda expression is a function that captures that context? That's plausible to me. Okay, so init, and it's going to take a symbol table, and it's going to take a lambda of lambda expression, and something's going to happen. Oh, he's got to call type. Super.init. I think his type is that of the lambda expression. Function foo goes to blah blah blah. All right, but it's almost, this is almost like a closure, right? It's wrapping up a symbol table context and the lambda expression. I hope. All right. I'm pretty confident this test will fail. I hope it compiles. Yeah, Elm expression not equal to function. Okay. Because we don't have an evaluate on lambda. So let's call this lambda. I'm going to make my test a little different. I really expect this, it just wraps lambda. Lambda expression name 42, that's the same thing as lambda. All right, the symbol table is there. Lambda evaluate with the symbol table is supposed to be a function. Okay, this will fail. And we need an evaluate, and let's get expression. Okay. Evaluate. All right, and the test failed. Error expression not equal to function. Okay. Right. Okay, and so I think we just want this to be function with symbol table context and lambda. Okay. Now function needs EQ. Okay. Whelm function not equal to whelm function. Yeah, we didn't add EQ. Let's push off this. Okay, so once again we're pushing a test context. Function expression. Oh, well, he doesn't even do anything yet. But if he did, yeah, let's check the equals. Okay, so in expression we need this thing. Well, I think again, let's steal the one from when we have lambda expression, EQ. We'll just borrow all that. And we'll return false for now. Okay, I guess I'm on my way towards a function test, huh? I hope I'm not just kicking the problem down the road. Well, that might even be helpful. Okay. Function tests. This This is function. Okay, so the expression, so we need function. I'm gonna make a symbol table. Let's see. Let's add the one we added over here. I'm gonna make 2 lambdas. Other. Okay. So if we make a function with symbol table, and lambda 1, and this is the same one, lambda 1 again. Okay, expression 1a should be equal to b. Now I'm just gonna worry about the one variable. Do we want to test the symbol tables for equality? Good. All right, I think the test is legit. Okay. I don't know if this is quite a story function expression, but we have to test for equality, and we want to do as string. Okay. I think I can at least do this. Okay. If other equals other as function, if it's not a function, it doesn't count. Name equals name. Function has no member name. Right, because well, let's store this. Let symbol table of symbol table. I feel like I'm writing Java. Self.symbol table equals symbol table. Self.lambda equals lambda. Okay, let lambda be of type lambda expression. Okay. Now, symbol table. I'm gonna say we'll just check this. And self.lambda equals other lambda. Take out this return false. I think I'm willing to do that. They have to be the same object. I think that seems fair. I don't know. I can't judge these symbol tables very well, and I don't want to dump the whole symbol table constantly. Ugh. Um. Well, let's do a test as string. Well, I guess first we can commit that. It tests all passed. Okay. Add function EQ test. Okay. Now we got function test as string, and we're going to create a lambda. Well, we're going to do this. Actually, I don't think we care what's in it, because I'm not going to put that in the function string. So assert equal. If you ask me for function symbol table lambda 1, I'm going to go back to calling this expression dot as string. Expression as string should be equal to function, I'll say table, symbol table, and the lambda value, which is this. Function table lambda, and the name here is going to be foo. Foo, and the expression is going to be 42 of type number. Run. All right. So it's time to stop. We should be on a failing test. Yeah, so expression print is not equal to all that stuff. I think we will stop there. Lambda foo number, I think I need one more parenthesis, but let's do that. Okay. We will stop there. We will pick up tomorrow, Code Wrangler, tomorrow 1 to 3 p.m. Eastern Time. And I think we're starting to break through the barriers on this. It's a tricky one. Once we get the function call working, I'll be relieved at that level. I think the parsing is still going to be an issue. But thanks for joining me. Sorry about the in and out and shuffling around. Just one of those things. Life happens. But see you again in the future, I hope. Take care. Bye-bye.